2005, these are all 2005. So for each of these tickers, I've simply extracted all the data that's there in 2005, and then a bunch of these over here, for example, for group 1, these tickers are stepping into 2006. So basically for these, I haven't extracted all of 2006. What I did was I extracted the data till April 2006. So kind of it takes care of even the last one, which is on the 22nd of December. You have till the end of April, so you should easily have your 100 days, right? So the data that I'll be giving you will not be nicely 100 days data. It could potentially be more than 100 days. So before you start analyzing it, you will need to clean your data. So for example, for this ticker, throw out everything which is outside this. This ticker, throw out everything which is outside this range. So you figure out how you're going to do that. Okay. Just to give you an idea of the data size, after I've cut it down, now it's fairly manageable. I think for different groups, because you have different years, the data size, the code file, which is the big one, code file size varies from anything from 12 million observations to about 40 million observations, 45 million observations, so it's not too bad. Yeah, so yes.
So here give us the ticker, what dates, we need to clean out our data, so it's only those dates that we're going to look for, right? Okay,
Yeah.
so that's the first step, and only then we will do our calculation.
Yeah, after that you start analyzing it. Right?
So it's from day 0 to day 100, so we study how, and the day 0 corresponds to an IPO, right?
Day 0 is the IPO.
IPO.
So TAG will most likely not have data for the first day, or it might not have, I'm not sure. Quite often it might have data only from the next day. For several of them it might have the first day, but it might sometimes have the first day missing.
But it doesn't matter, it will just go to the side.
In fact, thank you. Now, what will happen is if, let's say, you strictly define this as, the IPO date as the day 0. So if for day 0 there is no data, it simply means that yes, there is no data for day 0 for that particular IPO. And that's what you will have to see for how many of your tickers day 0 data is missing. Okay? If a lot of your IPOs day 0 data is missing, and then you start calculating the averages, day 2 sample will be different from the day 1 sample. And in that situation, you might even consider dropping the day 0, right?
But so that means when we have to look at every IPO, and if day 0 is missing, we'll have to do day 1 to 100?
Yeah.
And why don't just include day 0? What, it will skew the data so much?
Your sample will be different. You might be comparing apples with oranges, right? You will have day 0 sample very different from day 1 sample. And when you're comparing the evolution, when you're comparing the changes in the adverse selection, if your sample is changing, what exactly are you comparing?
So that means if day 0 is missing, does it mean that day 1 becomes day 0 or just?
No, day 1 does not become day 0. What I mean is that you look across your sample and see, okay, so for example, group 1, you have, say, 66 tickers. Now take a look at out of the 66, how many tickers are missing day 0. Okay. Now, suppose 40 of these tickers don't have day 0. What do? You can't really do much of an analysis with 25, 26 tickers. So let's just drop day 0 and start looking for day 1. Okay.
But it means for some tickers there will be day 0 on the graph, and for some.
But you will drop the day 0 for your entire sample. Yes. You will not use day 0 at all.
So let's drop it.
Pardon?
So let's just drop it. If there's.
I don't know how many tickets you will have day 0 and how many you might not have.
What's the greatest number you can have without it?
It's, in statistics, I can't really give you a strict number. You will have to make some judgment call. At that point, if you run into any trouble, you feel free to send me an email and say, okay, I've got 35 missing. guessing and I've got 32 available. Should I do it? Shouldn't I do it? I might even say run your entire analysis from day 1 to day 100 and run on the subset of 32, calculate the day 0, and maybe for that subset of 32, tell me what it looks like for the entire 0 to 100. Different things you have to play around. That's the whole idea of research. We don't know all the answers from beginning.
Excuse me, sir.
Yes.
If we have to drop the day 0 data, would there be any negative influence on our final results?
No, you're dropping the entire day 0. So, your picture will basically look from day 1 to day 100. So there is no day 0 in your analysis.
But would that make the final results not that precise?
Why? What is your final result?
I don't know, I just think whether there.
What are you looking at in the project?
I think if the final result, a good final result would be good if we found some significant influence on the outer proxies on the first selection. But I'm just wondering whether.
So you have got different hypotheses for different time periods. I mean, we talked about in our meeting, we talked about the quiet period, we talked about the rule 144, 171, we talked about when the insiders come in the 30 days, in the 90 days. We talked about how after the quiet period these guys come inside. So you have got different time periods. You're not looking at any one particular day. You're looking at from for the first 30 days, 30 days to 3 months, beyond 3 months. So you have different time periods. Now, and you're looking at the evolution. Maybe you just don't have the first data point. You have the second data point. So you're not really running one linear regression on anything. I mean, you're right that if you are going to run one linear regression on your entire sample, and the left tail has been truncated off, then that's going to affect the result. But you're not really doing that. That's not part of your analysis. Okay? Kind of answers your question.
Yeah.
Any other concerns? Most of your data, I have extracted it. I think group 5, I should have it by the time the class gets over. You should have extracted it. All the data is extracted. So feel free anytime to come by my office and collect your data so that you can start working with it. Okay. Sunday will be the last meeting of this class. Coming Sunday. So today's Thursday, tomorrow Friday, Saturday, and then Sunday. Yeah.
Are we supposed to submit the summary for
Absolutely. It's like next week's class.
So whoever has the presentation, it should be Sunday.
So instead of next week Thursday, we'll be doing it on Sunday because I'm away next week.
So this Sunday is next class after tomorrow?
After 2 days. Pardon?
This Sunday?
Yeah. So after 3 days. I mean 3rd day from today. So the details. That's why you should visit the message board.
There's a typo there.
So yeah, this will be very. After this, we'll not have any more classes. Tell your presentation. The presentation, I believe, is scheduled for again a Sunday. Is that the 25th or something around that, right?
24th, I think. Right. We don't have coffee anymore. No. You have to come.
We have to come like every day.
We have 2 weeks exactly.
That should be Let me double check. It's either 24th or it's the 31st. When did we decide?
It's the 24th because the 31st is Easter, so we decided on the 24th.
Ah, okay. Yeah, so 24th. Don't really have much time, do you? No. So, basically,
But
yeah,
the-
you have
sir-
probably.
But for the 24th, it just will present the result. Do we have to explain it or
No,
just?
it's the results, but then actually generating the result is what's. I mean, you'll be presenting the result and you will be talking in terms of the hypothesis which you have submitted to me in your literature reviews. So your results, how do they support or go against what you have argued in your hypothesis, right? And after your presentation, you will have about a month's time because I want the report, I believe, by end of April.
Yeah.
So
28th, I
you will have about a month to basically sit down and put it all together. But yeah, I mean for 24th, so that's why I actually collect the data as soon as possible. Next week I'm away, so you will not be able to get it. Best thing collected either today or tomorrow. Okay. Or latest by Sunday, you definitely pick it up. So that yes, in fact, in finance research. Thank you. In empirical finance research, and I'm sure at least some of you who have worked on some papers, research papers, would have realized that about 70% of the work is simply cleaning and analyzing the data. Okay? About the writing part is the other 30%. Finite statistics and data can be really, really messy. So, I mean that's why yes, you have very little time. You have about 2 weeks' time. Collect the data, analyze it. Okay. Anywhere and yeah, you should be fine. We have laid out. I mean, we have discussed what you're supposed to do in the methodology. You'll come in for analyzing the trade in the code. Once you have sort of identified your 100 days, once you have obtained your 100 days, after that analyzing it, you'll be. I mean, I've already given you the program, right? Now, in that particular program. Anywhere, and it is going to generate a lot of variables, okay? You don't need all of those variables. So the variable which you should be looking at are basically effective spreads, quoted spreads, what else? Price impact, okay? For price impact, the program generates two price impacts, dollar price impact and percentage price impact. Now what they call percentage price impact is the price impact which is there in the algorithm paper, the Hendershot algo paper. So to make sense of what that what that price impact is, you can read this paper, but this is a 85-page long paper. It's fairly lengthy. So I suggest go back to the Hendershot paper which we have covered in class and look at their section on liquidity. They have discussed realized spreads and they have discussed price impact. And the sum of the two is the implied effective spread. So from there, basically, the Hendershot's price impact. Hendershot's price impact is the percentage price impact which this data will be generating. This program will generate. And the Hendershot's realized spread is the percentage realized spread which this program will be generating. The program generates two price impact data sets. One is a tick by tick data set, and the other one is a daily average. I suggest you use the daily average. Okay. So I think the data set name will be price impact underscore daily average or something like that. So go to the daily average and use the price impact percentage and the realized spread percentage from there. Okay. Couple of things. Okay. Part 1 of the code, which does the reading of the data and the cleaning of the data. Okay. Now in this, you will notice in the code, I have forgotten, rather I've missed one filter. So don't remember to put that filter in. Simply throw in any spread which is greater than $5, drop it. Okay, so how will you do that? Simply absolute value of bid minus offer. If the bid minus or absolute value of bid minus offer is greater than $5, delete. Okay, so remember to put that in the step 2, which is the cleaning the code data. If you don't do it, you might have a spreads of $1,000, which is going to skew all your results. Okay. What else did I have anything else to?
Sir?
Yes.
You said that there was a paper we did in class in this liquidity section, but what's the paper again?
Hendershot, algorithmic trading. We have covered one paper on algo trading. It was week 6. Terence Hendershot, Jones and the Albert and Megveld. Does algorithmic trading improve liquidity? I believe your group presented it. Group 1. Group 1. Okay. That reminds me, yes. I think since yesterday I've received most of the presentations. Those of you who have not yet sent me the presentation, please do that. Okay, so that by today evening I can post all the presentations. Others will have something to refer to. What else? Any questions about the project? Anything? Any questions or concerns? Anything? Good. Was this off all the time while I was talking?
Yeah.
It was off.
No.
Nobody pointed it. Okay. So yes, the P1 is the program which does the reading of the data and the cleaning of the data. This is the step 2 that I was talking about, clean code data. Here are the bunch of filters which are inserted. So if offer size less than 0, bid less than 0. Similarly, you can throw in simply
more than that great.
Greater or equal.
Sir, can I ask you? We have 2 price impacts, dollar and percentage, right?
yes, you'll have dollar price impact and percentage price impact.
And what do we do with it?
Just use the dollar price impact. You don't have to, sorry, percentage price impact. Don't have to worry about the dollar price impact.
And percentage is tick by tick and daily average, right?
They're both,
I mean, we have 2 percentage, tick by tick and daily average. And we use only daily average, right?
Sorry.
And we use price impact and realized spread in percentage.
That's
So your output folder will contain project.ns, the NBBO dataset. NBBO dataset will have all the NBBO codes. It will have quoted spread dataset, which will have all the spread-based liquidity measures. In fact, actually, you don't have to go to any of these datasets. All you need to do is go to this one. Now, this file, price impact, will contain tick-by-tick price impact. It will also contain the best bid and the best offer. It will contain the transaction price. Okay? You can easily calculate quoted spread, which is simply the asking price minus the bid price, right? So offer minus the bid. Effective spread, which is simply 2 times quote midpoint minus the transaction price. The data set does contain quote midpoint, so you'll have the quote midpoint, you will have the transaction price, you can calculate the effective spread. You will have the best bid and the best offer, from that you can calculate the quoted spread. And it will have the tick by tick price impact. You can calculate the average or the median from the code. Sorry?
Is it already in the code that you posted, or should I?
Yeah, it's already there in this code. This is the code which is posted. So this particular data set, the price impact, so that way in your output, while this program is going to generate maybe about 8 or 9 output data sets, you don't have to go to all the data sets and dig around. Everything that you need for this project will be there in the price impact data set.
And for quoted market price, we also need the best bid and ask?
Sorry?
For the quoted market, midpoint, I mean, or...
Quote midpoint is a variable in this. It's already calculated. And what else? Yes, I did say that you will be required to calculate the Gloucester and Harris lambda. For that, again, the same file, it contains the sign of the trade. Okay, so it contains, it doesn't have -1 + 1, it simply writes SEL for sell and BUI for buy. Now it uses you will find 3 different columns of signs. One is the LR, which is the Lee and Reddy. This is what you will be using. Apart from this, it has got 2 others, ignore them. There's the Easley O'Hara and there is Van Ness and others there. So those 2 you can ignore them, just stick to the Lee and Reddy. Okay, so it simply calls it, I believe, yeah, number, you will have underscore LR with the sign. These are the other 2, the EOH and the CLNP. This is the Van Ness one and this is the Easley O'Hara one. Ignore them.
What's the LR for?
Lee and Reddy. Lee and Reddy, that is the algorithm that you have studied and we have covered in class for merging the trade and the quote data. Okay.
Sorry?
Yes.
Sunday, the class is in usual time, yeah?
11.
It's posted, it's for
It's
11
11.
o'clock.
So we can come right after class, collect the data?
You can come even today.
That'll be cool.
What else? What else? What else? Did I have anything else to mention? No, I think. So yeah. So for your project, what I want you to follow. Please do not talk. I don't have to keep repeating that. It's a small class. Murmurs echo. Quoted spread. Effective spread. Percentage realized spread. Percentage price impact. These two, how to interpret them, look at the Hendershot paper. And finally, Gloucester and Harris lambda. You will need to calculate this. So for this, we will get the you will get the signs from here, right? You will get pretty much all the inputs from here. You will get the signs, the trade size, the price, everything you get from here. You will have to run a OLS regression with no intercept. So
Euler's regression?
pardon?
Euler's regression? What kind of regression?
OLS. Yeah. So you'll be running a simple OLS regression with no intercept. The model was yeah. So this is the model. PT minus 1, so difference in the transaction price. This becomes your left-hand side variable. Right-hand side variable is the difference in the signs. So QT is just the sign of the trade. It's -1 if it's a sell, +1 if it's a buy. So QT minus 1 becomes your first right-hand side variable. QT VT, where VT is the trade size. Again, the price impact file will tell you at what price, how many shares were traded. So you will get the trade size from there. So signed trade size, difference between that. This becomes your second right-hand side variable. Third right-hand side variable is just the contemporaneous sign. That's the sign at time t. And the fourth right-hand side variable becomes the signed volume, which is the contemporaneous. So this is the difference, this is the contemporaneous. The difference, the contemporaneous. And difference in the price. And as I said, no intercept. Okay? Run the OLS regression. And what I call lambda is this guy alpha. So just to keep it consistent.
Lambda is the alpha, yeah?
Yeah, this alpha is what I keep referring to as lambda. Kyle called it lambda, so that's a symbol which is stuck. But yeah, so once you have run the OLS regression, you will get the C0, C1, Z0, and Z1, the 4 parameters, the coefficients. Forget the 2 and 2 will cancel out. So basically Z0 plus Z1 V bar divided by Z0 plus Z1 V bar plus C0 plus C1 V bar. This guy is the percentage of the spread which is due to adverse selection. Okay? Now, if you take this alpha, multiply it with spread. So this is the percentage of the spread. So when you multiply it with the spread, which you've already calculated, you will get the dollar adverse selection. And since you're comparing across the stocks, since the spread is a function of the size of the price of the stock, you need to standardize it. You can't just club them together. How do we standardize it? Dividing the price. So transaction price. Right? So
I need to get the relative.
once you've got the alpha, you will get the alpha, you run the regression for the day. Okay? It's an IPO, so you should have enough data points. Now, but some of you who are using, who has, particularly I believe the 99 or the 2000 IPOs, you might, or even the others, sometimes look at how many data points you have in a day. Okay, trade, not the code. Code there are plenty. Trade data points. So look how many data points you have in a day. If you have got more than 20 data points, run the regression. If you have actually even, you could even stretch it to 16. But if the number of observation on the day gets less than 16, then running the regression is really not a good idea. Let me know if you run into that problem of, that's what we call a thin trading. So suppose the trading is so thin that you're not able to run this regression within the day, then we can make it weekly. Okay, we can even make it 2 days or something like that. So get back to me if you run into thin trading problem. But yeah, basically, so we'll have 1, 2, 3, 4, 5, 6. So these 6, you will be observing their evolution for the 100 days. You will have the daily numbers, and that's it. First phase, get this done, and report to me what the numbers are. I'm not sure if there is time to go into the second part, but anyway, get this done first. Okay, questions? Most of your hypotheses which we discussed in our meeting, you should get indication by simply looking at the patterns in these. Okay? Questions or concerns, you think? Okay, good. So we have
This
yes.
we need to do for each and every one tick, or it does automatically for the ticks and then it shows.
Sorry.
All those 6 steps, we'll need to do it every time for each stock, or it does automatically in the program?
No, the program has generated these guys for you for every stock.
And we have to do number 6.
You'll have to do this guy. But the program will give you all the inputs which you need to run this regression. Thank you. All right, I think that was important. Maybe we'll be able to cover again these 2 papers, but which group is coming first?